In this chapter and in the coming lectures, we are going to talk about transactions in the main. But of course, first of all, we have to understand how to lock a given database table. So this is why we have to talk about these topics. So first of all, what is a transaction? Most of the SQL statements are independent of each other, and basically most of the queries we have been talking about in the previous lectures and in the previous chapters are statements that are independent of each other. Whether we update a given database table, whether we create a given database table, whether we select a given row from a database table, these queries are totally independent of each other. But of course, there may be several SQL queries that need to be executed together right after another as a single logical unit of execution. And basically this is why transactions came to be. So transactions help to execute multiple SQL statements at the same time. The problem is that multiple users can manipulate the same database table at the same time, and this is why we have to use locking techniques in order to avoid inconsistencies. So first of all, let's talk about locking. The database server uses locks in order to handle simultaneous use of data resources. If the database is logged, then any other users or sessions wishing to modify, such as update or read that data, must wait until the lock has been released. And by the way, there are several strategies to handle concurrent modification. First, we can use locking, and the second approach is called versioning. So first of all, let's talk about locking. There are two main types of locks. We have the write lock and the read lock. So database sessions must request and receive a write lock from the server in order to modify a given data, but it is absolutely crucial that it may happen that a given user or a given session just want to read the given data without modifying it. And this is when read locks can prove to be extremely useful. So the crucial difference is that only one write lock is given out at a time for a given table, because of course problems may arise when dealing with write operations. If a given session wants to read the given rows in the database table, then of course it is not a huge problem. Problems may arise when multiple users and multiple sessions try to manipulate and update the same database table related data. So basically when dealing with write operations. And of course only one write lock is given out at a time for a given table. This is how we can avoid inconsistencies. So database readers must request and receive a read lock from the server to query the data, and the advantage of read locks is that multiple users can read data simultaneously. And it is absolutely crucial that read requests are blocked until the write lock is released. So for example, Microsoft MS SQL Server uses this locking technique, and of course every single approach has disadvantages. In this case, the problem is that it can lead to long wait times. Okay, so let's compare read locks and write locks. As far as read locks are concerned, multiple users or multiple sessions can acquire the read lock at the same time, because of course reading the data is not going to change the value. So it cannot happen that the database table will end up in an inconsistent state. So this is why multiple sessions can acquire the read lock at the same time. The session can read exclusively while holding the read lock. Of course, no write operations are allowed, and other sessions with the write lock has to wait for the read lock to finish execution. So as far as the write lock is concerned, so every single user or session that acquires the write lock can read and write as well. Other sessions cannot even read from the database table while the write lock is not released. So this is why usually the read lock is called a shared lock and write lock is called exclusive, in the sense that only a single session can acquire the write lock at the same time. And of course every other session has to wait for the write lock to be released. I'm not sure whether you are familiar with multithreading in, for example, Java or C++, but it is very similar to multithreading. that we would like to make sure that the database table is not going to end up with an inconsistent state. Okay, so this is the crucial differences between read locks and write locks. Of course, there are several approaches. We can lock on the table, we can lock on a given page, we can lock on a given row. So as far as table locking is concerned, only a single user can manipulate a given database table at a given time. Of course, it is the easiest approach, so it is quite easy to implement it, but it is quite a slow approach. Because of course you may guess that what if the first user tries to read the first row of the database table, the second user tries to read the second row of the database table, the third user tries to read the third row of the database table, then of course it may happen without any issue because they just want to read different rows of the database table. If we lock on the database table, then of course the sessions have to wait for each other to finish, despite the fact that these operations may be totally independent of each other. So it is quite easy to implement, but it is not the fastest approach possible. What about page lock? Only a single user can manipulate a given page at a given time. A page is a segment of memory, usually between 2 to 16 kilobytes. We are going to talk about pages and the paging techniques in one of the coming chapters, and it is going to be clear. And we can use row locking when only a single user or a single session can manipulate a given row at a given time. Of course, it is a fast approach, but it is not that easy to implement because we have to store some additional information. By the way, MySQL can use all of these techniques. As far as the Oracle database is concerned, Oracle database uses row locking. Okay, so that's all about the locking technique. The second approach is the so-called database versioning that allows multiple users or sessions to read and write data at the same time. And the server ensures that data will be consistent by keeping multiple versions of the data itself. So there may be multiple versions of the data visible to multiple transactions, so multiple sessions. And when a given session or a given transaction modifies a record, a new version is written to the database. So there's going to be multiple versions of the database itself. As far as MySQL is concerned, it uses all of the techniques. As far as Oracle is concerned, there may be a problem if there are long-running queries while the data is being modified, but anyways, we are going to focus on MySQL. So this is the so-called versioning approach. And finally, let's talk a bit about storage engines. So we have been talking about the locking techniques, and MySQL supports several locking strategies, and we can specify what we want to do. And it is crucial that there are several so-called storage engines for MySQL. So for example, we have MyISM, that is a non-transactional engine with table locking, and there is another storage engine called InnoDB, which is a transactional engine with row-level locking. So what does it mean exactly? First of all, that MyISM is using table locking while InnoDB is using row-level locking. So this is what we have been talking about a few minutes earlier, that what is the crucial difference between table locking and row locking. So this is the first difference between the two storage engines, but the second crucial difference is that we are not able to use transactions with MyISM. So this is why we are going to use InnoDB, because we are going to use transactions. So this is what we are going to talk about in the coming lectures. And of course, we can check a table storage engine with the help of this SQL statement. Okay, so let's take a look at it. So for example, we are curious that show table status where the name of that given database table is equal to the city. Okay, let's run it. And as you can see, there are lots of information concerning this city database table. What's the name of the database table, city? What's the version? What's the row format? How many rows we have within this database table? What's the average row length, and so on. But what's very important, that we have the engine InnoDB. which means of course that we are using InnoDB with row level looking. And of course row level looking means that only a single session or a single user can manipulate a given row at a given time. It is a fast approach, but it is not that easy to implement it because we have to store some additional information. And of course we can alter a given table related storage engine with the help of the alter table keywords. Okay, so I would like to show you that it's working fine. I would like to alter the table city. I would like to set the engine to be equal to INNODB. Okay, so let's run it. And as you can see, we have managed to alter the table engine to be equal to INNODB. Okay, so this is how we can make sure that we are going to use InnoDB, and it is going to be crucial because InnoDB supports transactions. And of course, we are going to implement transactions. So this is why it is crucial to make sure that we are using the valid storage engine. Thanks for watching. In the previous lecture, we have been talking about how to avoid inconsistent states with the help of looking, and in this lecture we are going to talk about transactions. So we can group multiple SQL statements such that either all or none of the statements succeed, because this is what we have been talking about in the previous lecture, that sometimes we have to execute SQL statements that are not independent of each other. So we have to make sure that either all of them or none of them succeed. And this is called the so-called atomicity principle. We are going to talk about these principles in the next lectures, but it is absolutely crucial when dealing with banking applications, for example. So let's assume, just for demonstration purposes, that a given bank's customer transfers money from a savings account to the current account. So what's going to happen? There are going to be multiple SQL statements. First of all, we have to update the savings account. So we have to do something like this. We have to update the saving account, set the balance to be equal to the balance minus 500 because the customer wants to transfer $500. So we have to decrement the value of the actual balance where the account ID is 123. So this customer is going to be identified by the primary key with value 123. But of course, we have to update the current account as well. So update the current account, set the balance to be the actual balance plus $500 because of course the customer wants to transfer $500 where the ID is equals to 55. And of course the bank wants to track everything, so we have to insert a new value into the log file. So these three SQL queries are not independent of each other. We have to make sure that either all of these SQL statements are executed, or we have to make sure that none of the SQL statements are executed. Because let's suppose the situation, then we have managed to execute the first SQL query and we decremented the balance as far as the savings account is concerned, but there is an error as far as updating the current account is concerned, and the balance is not going to be incremented by 500. This is when the database will end up in an inconsistent state because we have decremented the balance as far as the first database table is concerned, but we have failed to increment the value as far as another database table is concerned. So what is the problem with these SQL statements? Here in this case, we handle every single query independently, but of course it is obvious that they are depending heavily on each other. So what can be the solution? The solution is to use transactions. So we should include all of the SQL statements within a single transaction. We want to make sure if one of the statements fail, then we roll back and make no change at all. So we want to avoid inconsistent states. And basically, if we use a single transaction for these three queries, then if there's an error as far as the second query is concerned, then there's going to be a so-called rollback operation, which means that MySQL is not going to change the savings account. So basically, this is the rollback operation when MySQL undo the operations. Okay, so this is how we can avoid inconsistent states. Of course, there are several keywords we are going to use. First of all, we can start a transaction with the help of the start transaction keyword. So this is how we can start a given transaction. There are the so-called commit keyword in order to save the changes. There's the rollback keyword in order to roll back changes, so undo operations. And we can define save points within groups of transactions in which to roll back. So these are the keywords we are going to talk about in the coming lectures. Thanks for watching. In the previous lectures we have been talking about locking, then we have been talking about transactions in the main, and in this lecture we are going to talk about the so-called ACID principles. So we have been talking about that a transaction is a single logical operation on the database data. For example, updating the name of a customer, withdrawing money from a bank account, and so on. What's crucial that a single transaction may involve multiple changes. So this is what we have been talking about in the previous lecture, that a single transaction may include multiple SQL queries, updating the saving account, updating the current account, inserting a log file into a log database table, and so on. So a single transaction may contain multiple SQL queries. And this is exactly why back in the 1970s, Jim Gray defined the ACID properties in order to make transactions reliable. Okay, so ACID stands for 4 principles. A for atomicity, then we have C for consistency, then we have I for isolation, and we have D for durability. So first of all, let's talk about atomicity. Atomicity principle requires that every single transaction can be all or nothing, which means that if one part of the transaction fails, then the entire transaction fails, so database state is left unchanged. This is the so-called rollback operation. So aborted transactions do not happen. An atomic system must guarantee atomicity in every situation, even when errors or power failures happen. So this is the first principle. What about consistency? Of course, we want to make sure that the database table is consistent. So consistency property makes sure that any transaction will bring the database from one valid state to another. The data inserted into the database must be valid, including constraints, cascades, or triggers. So for example, if we are dealing with a transaction with these 3 SQL queries, then of course we have to make sure that the data is going to be consistent. What does it mean? That the balance will be decremented by $500 as far as the saving account is concerned, and on the other hand, the balance in the current account will be incremented by $500. So this is called consistency, that the changes are going to be self-consistent. Okay, so this is the second principle. Then we have isolation. The isolation property ensures that the concurrent execution of transactions result in a system state that would be obtained if transactions were executed serially, which means that in a sequential manner, so one after the other. It is basically a concurrency control. The effect of an incomplete transaction might not even be visible to another transaction. So it is absolutely crucial. Okay, and finally we have durability. The durability property ensures that once a transaction has been committed, it will remain so. Even in the event of an error or a power loss, the effect of the transaction is going to be committed. In order to defend against power loss, transactions must be recorded in a non-volatile memory, so for example in the HDD, so in the hard drive disk. Okay, so these are the 4 ACID principles that are crucial as far as transactions are concerned, and in the coming lectures we are going to talk about how to use transactions with SQL and MySQL. Thanks for watching. Hi, in this lecture we are going to talk about transactions in the main. So first of all, we would like to select everything from the person database table. Okay. And if we run this query, of course, there's going to be the persons with the person name, person age, university ID, if there is a university associated to a given person. Okay, so first of all, if we would like to start the transaction, first of all, we would like to set auto commit to be equal to 0. What does it mean? That we would like to make sure that MySQL workbench is not going to commit the changes immediately. Okay, because we would like to control that commit with the help of the commit keyword. So we would like to make sure that, for example, I'm going to update the person database table and I would like to set the university to be equal to 2 where the person ID is equal to 1. So I would like to update as far as Kevin is concerned, and instead of attending the university with university ID 1, I would like to make sure that Kevin is going to attend the university with university ID 2. Okay, and after that I would like to call the commit. So first of all, let's run this set auto commit 0. Then of course I would like to select everything from the person. Okay. Then I would like to update the person database table and set the university to be equal to 2. Let's run it. Then we would like to commit the changes. And if we select everything from the person table, then as you can see, Kevin has been updated and the university ID has been changed. So basically, when we call the commit keyword, it means that, okay, first of all, if we use the set auto commit equals to 0, it means that we start a transaction. There are several ways to start a transaction. For example, we can call explicitly that I would like to start a transaction. Okay, something like this. By the way, we could use something like the begin. Okay, like this. But if we call the set auto commit equals to 0, it's usually enough. But okay, let's start a transaction explicitly. Okay, and basically if we start a transaction in MySQL, then there are two ways to finish our transaction, either with commit or with rollback. This is what we are going to discuss. If we call the commit, it means that we would like to make sure that MySQL is going to finalize or update. So we would like to call commit, which means that, okay, we would like to save our changes to the database. Okay. If we call the rollback, it means that we would like to undo the changes. We would like to make sure that this update is not going to happen to our database table. Okay, so we set auto commit 0, we start the transaction, we update the person table accordingly, and we commit. Okay, I'm going to comment it out, something like this, or I'm just going to get rid of this. Okay, so we start the transaction and this is how we finish the transaction. This is how we tell MySQL that, okay, we would like to make sure that everything within this transaction has to be valid. We would like to commit the changes and save the changes into the database. So this is how we start a transaction. We set the auto commit to be 0 because by default MySQL Workbench is going to commit every single line of SQL statement. In this case, we would like to make sure that, okay, after we call the commit, that's the time when we would like to finalize our results. Okay, so we start the transaction, we update the given database table, and we save the changes with the commit. In the next lecture, we are going to talk about how to roll back some changes. Thanks for watching. Hi, in the previous lecture, we have been talking about how to set auto commit to be equals to 0, how to start a transaction, and we can use the begin keyword instead of the start transaction. We update a given database table and then we commit the changes. And what if, for example, in this case we select everything from the person database table, and as you can see we have the university ID 2 associated with Kevin. For example, we would like to update it again, the university back to university ID 1 for Kevin, so where the person ID is equal to 1. And let's take a look at the rollback statement. So we set auto commit 0 again, we start a transaction. Okay, we select everything from the person table just to make sure that we track that, okay, the university ID is equal to 2 in this case. We update the person database table and set the university ID to be 1. So as you can see in this case, university ID is 1. And then we roll back. What does it mean? If we call the rollback, it means that we want to get rid of the updates. Okay, and we made a single update and basically we updated the university ID to be 1. So after the rollback, all of the changes in the transaction is going to be lost. So let's select everything from the person. As you can see, everything has been restored. So basically, if we roll back, we are going to restore the state before the transaction. So if we commit, then we are going to save everything within the transaction. If we roll back, then we are going to make sure that nothing is going to be saved in a given transaction. So as you can see, we have set the university ID to be 1, but after rollback, the university ID is equals to 2. So basically, like nothing has happened. So we have managed to get rid of the transaction as a whole. Okay, so this is how we roll back changes with the help of rollback, and this is how we commit changes and save changes with the help of the commit statement. Okay. In the next lecture, we are going to talk about save points and how to roll back to previously specified save points. Thanks for watching. Hi, in this lecture we are going to talk about save points, because in the previous lectures we have been considering the commit and the rollback statements, and we have been discussing that for the rollback we are going to roll back the entire transaction. But sometimes we don't want to roll back the entire transaction, we just want to roll back to a certain point in the given transaction. And this is why save points came to be. So we have this Udemy person database table. I'm going to get rid of Udemy. So first of all, let's run it. Okay, this is the table we are going to manipulate. Of course, we are going to set the auto commit to be equals to 0. We are going to start the transaction. Okay, and then we would like to have several updates. For example, I would like to update the person database table and set the person name to be equals to Kevin B, for example, instead of Kevin, where the person ID is equals to 1. And I would like to make several updates. So for example, I would like to update again the person database table, and I would like to set the university ID to be 2 instead of 1, where the person ID is equals to 1. So we would like to update the name of the first entry, and we would like to update the university ID associated with Kevin. Okay, of course, if we have the rollback, then all the changes will be rolled back. So we are going to roll back the update for the university and the update for the person. But what if we would like to roll back the last update exclusively? This is why we have to define the save points. For example, we will have the save point save 1, then we will have the save point save 2. Okay. So I'm going to set the auto commit to be 0. I'm going to start the transaction. I'm going to select everything from the person, so we know that we have the person name Kevin and the university ID 1. Okay, so first of all, let's save the save point 1. Okay, let's update the person and set the name to be Kevin B. So if we select everything, as you can see, the person name has been updated. It's very important to see because when I first met with the commit statement, it was quite counterintuitive that, okay, we haven't called the commit keyword, so why there's an update for our database table? Because basically it is a local change. If we call the commit, it means that our change will be final. Okay. So we updated the person table. I would like to save the save point 2. Okay, I would like to update the university ID to be 2. So in this case, we have the Kevin with Kevin B and university ID 2. And for example, we would like to roll back to the second save point, save 2. What does it mean? That basically we would like to undo the last update. So the university ID, we would like to make sure that it's going to be 1 again instead of 2. We just have to roll back to save point 2. Okay, so if we run it and select everything from the person, as you can see, we have managed to roll back to this point in the transaction. And it's like we haven't run this SQL statement, because here we updated the university to be equals to 2, but after the rollback, it's going to be restored to be equals to 1. Okay, so this is how we are able to roll back basically changes. And for example, I would like to roll back to save point 1. Okay, let's run it. And if we select everything from the person table, as you can see, we have managed to get back to this point in the transaction. So we haven't updated the Kevin, because as you can see, after the rollback operation, the person name is Kevin and not Kevin B as we have updated. The university ID is equals to 1 instead of 2 as we have updated. So this is how we are able to roll back to save points we have defined, and of course we are able to get rid of save points. For example, we would like to get rid of the save point 1, then we just have to type release save point save 1. Okay, in this case we are not able to roll back to save 1, there's going to be an error. As you can see, save point save 1 doesn't exist. Of course, because we have released that given save point. So this is how we commit, and this is how we roll back a transaction. And sometimes it's important to roll back to a given location within a transaction, and that's why we are able to save points and we are able to release save points. Thanks for watching.